We're on problem number 2 now. And before I move forward, I want to just remind you who I am. I'm Ron Bannon. If you need to reach out to me, my email address is Bannon, that's B as in boy, NNON.US. All right? Why would you want to reach out to me? Reporting an error in the document or some inconsistency in what I'm saying in the document. All right? So this one over here says consider the linear system. And what I mean by that, when I'm considering this linear system, this is a line, that's a line. What are they really looking for? They're looking for you to graph those two lines and determine a point of intersection. So what I want to do is I want to cut to the chase. This is number 2. And number 2, if you read it, it says it's figure 27 and page 588. Okay? So what I want to do is I want to do one line at a time. I'm going to talk about this one over here, and that's going to be 3x plus 7y equals 5. What I'd recommend you do is pick easy values. And again, we're graphing 3x plus 7y equals 5. My recommendation is pick values that you find easy. Now, I'm going to say that choosing x to be 0 is not a bad idea. And what would you get over there? You would get 5/7. And choosing y to be 0 is not a bad idea. What would that give you? Well, that would give you 5/3. I'm going to graph it, those 2 points. And I got to be honest with you, it's never like an easy thing to do. But I have an understanding I can graph these points over here. So if the first point I would graph is, let's see, it would be 0 along the x-axis, but 5/7. And 5/7, it's about up here somewhere. And the next one is I have to do the x now, which is 5/3. That's 1 2/3, so over here somewhere. And then what I would do is I take my ruler, and it's never great. I would take my ruler and I'd try to graph a line through that, all right? And I'd say that goes on forever. That line's done. Let me go to the next line. I want to do this line over here. So I'll put my little table down, x and y, and I'll write the line down. It's 8x plus 3y equals minus 18. And again, I'm recommending the use of graph paper. So what I would do over here is I would just pick an easy value. For example, I would pick x to be 0, and what would y be? Minus 6. That's easy. Let me keep going. Let me choose y to be 0, and then what would you get? You would get minus 18/8. Well, I need to reduce that because it looks kind of crazy to me. It's minus 9/4, which I hope you realize is minus 2 1/4. All right? I'm going to graph that now. I'm going to do that in blue. So I'm going to graph actually this point first. So that's going to be minus 2 1/4 on the x-axis, so over here somewhere. Now I realize what some students are saying. I don't see where that I could plot that. If you have graph paper, and I'm going to extend this now. If you have graph paper, I'm going to say minus 6 is over here somewhere. So I'll put that point down in blue. So that's going to be 0 minus 6. And this is crude. There's no doubt about it. It's crude. So what I need to do is take my little thing over here, and I'll do this over here. You know what? It's not lining up nicely, is it? Let me just get that to get a little bit better. And I'll put this, and this is the problem with graphing. And really, it's an awful technique, unless you have really accurate graphs, by the way. So let me draw my line in now. All right? Yeah, I'm a little bit off. Let me get rid of my thing. I'll put my arrow here going that way, and I'll put my arrow over here going this way over here. Now here's the problem. I'm looking at this. I'm looking at a point of intersection. Now, my gut feeling is if it's not easy, I'm not getting it. Like if it was like a really wacky looking fraction, like 2 1/172, I'm not getting it. That's for the y, by the way. So I'm going to make a stab at it by just looking at it. And the stab is going to be, what does it look like to me? Well, if I looked at it, it looks like about minus 3 along the x-axis. But you know what? If it's not minus 3, this is just not going to work. right? So that's why it's so important to check it. And what does the y look? It looks about 2. But I don't know if that's right. I could say that looks like that and realize that graphing is very imprecise. I want to check it. I'm going to check it. And where do you check it? In the original system. Well, in the first equation, what would you get? You get minus 9 plus 14. And does that equal the number 5? Of course it does. That's good news, by the way. Don't think it's good news in the second one. Second one is minus 24. And then what do you get? Well, that's 3y, right? That would be 6. What does that give me? Minus 18. So now I'm convinced that's the correct answer. But let me repeat this. Your lines are going to be very imprecise, right? What I say is try to ballpark where it is. Use integers. If they're not working out, you're in trouble. There's got to be another technique, by the way. Thank you.